Hi everyone, so after seeing how to find the PMF and CDF, now it's time to find the expected value and the variance. Actually, what does expected value actually says? It's like if we play this game a million of times, how many heads do we expect to get on average per game? How many of heads I expect to get actually. So um, here the difference between the expected value and the mean, which is x bar, is that the mean is in the mean each value in our data set is weighted to its frequencies, but here in expected value each value of our random variable is weighted to its probability to appear. So how to find the expected value? Simply, it's the value of it's each value of our random variable. For example, here we have 0. We multiply it by its probability to appear. So the probability of getting a 0 head in this experiment, we multiply it. So it's 0 times 1.5, we get 0. And then for the second value, so the probability of getting a 1, we know that it's 2/4, so we multiply this value by its probability, we get 2/4. Then finally the last value is 2 and its probability is 1/4, so it is 2 times 1/4. As we said, we weight each value by its probability to appear. Then the total, our total, here it is 1, but it doesn't mean that we must find 1. No, it's different than this. Okay, so it's simply the total. Whatever the number you get, that's the expected value actually. As I said again, x bar, we take each value, and in our data set, not here, we don't have here x bar, so we take each value in our dataset, we weight it with its frequency. It's weighted to its frequency. But here in the random variables, we take each value and we weight it to its, the weight of each variable is actually, each value of this variable is its probability. So here is the formula for the expected value. So x is the sum of all xe times pe. Pe is the probability, xe is its value. So we multiply this by this, we get here the xep. So for each value, in the end we take the sum. This sum is our expected value. So what does this mean? If I play this game millions of times, I expect to get an average of 1 head, because I have 2 coin game. So if I threw a coin twice, I expect to get 1 head, which means 1 head and 1 tail, because the probability here is 50% for each one. Now let's see the variance now. So the variance, how much variation is there around that expected 1 head? So the formula, if you remember in when we studied the moments, we know that Vx, which is the variance, is actually the second central moment equals the first row moment, the second row moment minus the first row moment squared. So here we have we know that the first row moment is simply the first, or is the expected value, is the mean moments. So it is instead of this, we can write the expected of x squared. And we also know that the second row moment is the expected of x squared inside. So they are not the same, okay? They are not the same. This one means the value we found here, we square it, while this one is actually we square the value of x, then we multiply it by its probability. So we need to square first this, like 0, here 1 square is 1 and 2 square is 4. Then we multiply these values by the probability to get this. So as we said, e here, e of x squared is the sum of x squared times pe. So 0 times 1 over 4 we get 0, 1 times 2 over 4 get 2 over 4, and 4 times 1 over 4 get sorry, actually it's hit this because this is x, not x squared. So 0, 2 over 4, and then 4 times 1 over 4, it is 4 over 4. The sum is 1.5. So in the end we get our variance Vx is 1 over 1.5 minus 1 squared, because this is 1, we take the square, so 1.5 minus 1 is 0.5. In the end we can get also the standard deviation, which is simply the square root of the variance, and we get 0.707. Now let's solve a simple exercise just for practice. Now imagine we have a NaN containing 2 red balls and 2 black balls. We drew 2 balls from a NaN containing red and black. So let the our random variable, which is a discrete one, count the number of red balls. So our interested, or the our random variable, count the number of red balls. How many red balls do we get from this draw? So logically our random variable can take different values. The first is 0. I can get no red balls, which means both are black. Maybe I can get one of them is black, that means the other one is red. I also can get 2, which means here both are red. So either both are red, or only one of them, or no one of them. So how to get the PMF, which is the probability mass function? I need to find the probability of each value. So what is the probability of x being 0? Px equals 0. That means, how to get this? That means I have no red balls. So in this case both balls are black. So in combination, how to find this? Here, since the order doesn't matter and the repetition here is not allowed, which means we have a combination here. So what is the number of combination that makes us get 2 red balls, or 2, which means I get 2 black balls? So that means I choose 2 black from 2 black. So the combination of 2 from 2, we know that Cn n is 1. So it is 1. This is the number of ways, but we need to divide, which replace our favorable outcomes. We need to divide it by the total number of possible outcomes, which is actually drawing 2 from 4, whatever the color, doesn't matter here. So this is our omega. So in the end we get px equals 0 is combination of 2 from 2 divided by combination of 2 from 4, which is 1/6. So we write here 1/6. Now, what is the probability of getting one red ball? So what does this mean? For omega, it is always 2 from 4. It doesn't change. Okay, this is the cardinal of omega. Now for the our event of getting one red ball, that means the first is red and the second is black, and here the order doesn't matter. So either the first is red, the second is black, or the first is black, the second is red. Doesn't change anything, so it will be counted as only one way. So this is the number of ways of getting one red ball. So we know that Cn1 is n. So here we get 2, here we get 2, which is 4/6. Here is 4/6. Finally, what is the probability of getting 2 red ball? So simply we said omega doesn't change, and the number of ways for this event is drawing 2 red ball from 2 red ball, and which is the multiplication, 0 from 2, which is 0 black from 2 black. We can cancel this since it is 1. So it is C2 from 2 and C2 from 2 is 1. So the final result is 1/6, 1/6. And the sum here is 1/6 plus 4/6 plus 1/6. It's 6/6, which is 1. We said the condition is that the sum of all the probability is 1. Now let's see a second example. Now we form a committee of 4 members chosen at random from 7 people. So I have 7 people, and n is 7 here, including 2 brothers. So from among the 7, I have 2 are brothers. We note x as the random variable equal to the number of brothers in the committee. So I want to know from these 2 brothers how many are in the committee. So what are the value that our random variable can get? So first is 0, which means I have none of them is in the committee. Maybe one of them, either A or B, one of those 2 brothers is in the committee. And finally 2, which means both are in the committee. So the omega, cardinal of omega, is simply choosing 4 among 7. So C4 among 7. Why it's combination? Because it's not we cannot take the same person twice, so repetition is not allowed, and the order doesn't matter. So the one I choose before the first as second, third, doesn't matter. So all they have the same task or the same job to do within this committee. So order here doesn't matter. This is why it's combination. Now let's see for the first case where our x equals 0, means none of these 2 brothers are here. What does this mean? That means all the 4 members of this committee are chosen among the 5 that are not brothers, so that exclude the 2 brothers. So all the 4 are chosen from the 5. So it is 5 over 35, because this one is 35. So it is and we know that c of n minus 1 is always n. So here c5 4 is 5, so 5 divided by 35, which is 1 over 7. 5 over 35 is 1 over 7. Now let's see for the second value, which is 1. So we know that we can have one of them in the committee. So how to get this? It's the probability of x equals 1 is cardinal of our second event of getting only one of them, divided by omega. We said omega cardinal omega is 35, which is c4 among 7. And how to get only one? That means I choose one from the two brothers, and the rest, which is 3 of them, the rest I chose 1, so the remaining is 3. The other 3 I choose them among the 5 remaining people. So this is the number of favorable outcomes. So, and the value of this is 20, which is 2 times 10, and you get 20. 20 over 35 is the probability that our x is 1. So 20 over 35 is 4 over 7. Now the last value is 2. So both my the two brothers are in the committee, which means I choose 2 from 2 among those 2 brothers. Both are taken, and the remaining 2, because I need 4 members, I will choose them among 5. So we get this c2 from 2 times c2 from 5, which is 10, divided by omega, which is 35, and the probability is 2 over 7. So the probability that x, our random variable, is 0 is 1 over 7, is 1 is 4 over 7, that x, our random variable, equals to is 2 over 7. And what does this mean? X equals 2, it means if we translate it to the physical outcome of this experiment, it means I get 2 red balls. Now let's see how, let's back to the first exercise, the first example, and let's find the expected value and the variance. Okay, so here our result. So the probability of x is 0 is 1 over 6, is 1 4 over 6. Probability of x equals 2 is 1 over 6. The total is 6 over 6, which is 1. Okay, the total must be 1. And this is rho is the fx of the CDF, the cumulative distribution function. So this tells the probability of x is less or equals 0, which is 1 over 6, and the probability of x is less or equals 1, which take the two value 1 and 0. So it's this plus this, we get 5 over 6. And finally the probability that x is less or equals 2, which means it takes all the value 2, 1 and 0. So it is either this plus this plus this, or this plus this. We get in the end 6 over 6, which is 1. So the probability that x is less than or equals to is 100%. Now let's see the expected value. We said the expected value is the sum of xc PE. This is our PE or PMF. We multiply it by the value of x, so we get 0 and 1 times 4 over 6 is 4 over 6, then 2 times 1 over 6, it is 2 over 6, and the sum is 4 over 6 plus 2 over 6, we get 1. This is the sum, and this is the expected value, x, the expected value. And what does this tell us? Actually, in this experiment, I expect when I draw 2 balls, I expect to get 1 red ball. And finally, Vx, which is the variance, we said it is the e of x squared minus ex squared. So what is ex squared? Is actually the sum of xe squared times p. So we square those values of x. We square this, for example, 0 squared, we multiply it by the probability, we get 0. We square 1, we multiply it by its probability, we get 4 over 6. We square 2 and we multiply it by the probability, we get 4 over 6. The total is 4 over 6 plus 4 over 6, which is 8 over 6. This is the total of this, and this replace ex squared. So we said Vx is ex squared, which is 8 over 6, which is 1.33, minus ex squared, the expected value we found here, we square it, which is 1. 1.33 minus 1 is 0.33. Then we have the standard deviation, which is simply the square root of Vx, which is the square root of 0.33, and it equals 0.577. This is the standard deviation. So thank you for watching, and see you in the next video with the continuous random variable.